Hi, I'm Don Widener. I'm from Stony Brook. And I'm really here today because I'm chair of a committee that Compress has set up, which is called the Long Range Planning Committee. Now, long range planning committees generally have fairly short range goals. And so the name may be somewhat of a misnomer. But the real motivation for this committee is the fact that Compress needs to prepare a proposal over the course of the next 6 months or so. And this proposal has to have a vision that goes forth for 5 years or more into the future as to how Compress will relate to the science community and to all of the facilities. And so this is a really important time because it means it's time to sit back and reflect on where we've been and try to vision forward a plan of where we want to be. Now, within this perspective, Compress, as Quentin has outlined very well, is a community that embraces much of what we call mineral physics, material properties in the depth of the earth, and how does the earth work, what is the earth made out of, what's going on. These all become the science questions that we need to address. And clearly, the computational community is a very vital part of this quest in the science. And so it's only imperative that this community be involved in these discussions and to help forge the plan as we go forward. Now, I'm not going to use any slides, so you're just going to have to look at me. That's sorry about that. So I wore my new shirt today, so that helps. So part of this makes me reflect on the origin of Compress, and Quentin also very nicely laid that out. But I would say that the imperative for the formation of Compress was the fact that there are national facilities available that gave us capabilities that you just could not have in your own laboratory, on an experimental basis. And I project that the same kind of thing may be true in the computational world. And so this makes a very interesting parallel. For example, a synchrotron light source in your beamline produces as many X-ray photons in a second as you would get from a lab source in something like 100 years. Right, so if you're doing experiments with a lab source, you have no idea what you can do if you had a synchrotron, because the magnitude, the scale is so different. And computationally as well, my laptop, I'm just delighted with all the calculations it can do. But I know that it has no chance to do what's available at computational centers. And so this imperative is to approach these very precious resources as a community rather than as individuals. And that's sort of a strange thing to do in our business because we're used to the highly competitive interactions that we all have, and that is a very good way for the science to grow and to maintain its purity and for truth to win out most of the time. But for the system to evolve is in this competitive nature. But the fact that the need to form a community comes to sort of bring all of these resources together so that each of us can have more access to the process. And actually, as individuals, we gain by it, but we also have to give up something in order to come together with it. And that's a very difficult task. And I don't want to minimize it. I think it's important to remain very aware of it. Now, the solution that Compress had to this issue, that the tangible solution becomes then this budget and building and supporting these beamlines. And there's a certain realism that comes into all of this. And, so maybe this is a little out of line, but I think one can focus on different amounts of funding, some which would be unrealistic and some which would be insignificant. And so it's worthwhile having a feel for what that range is. And I would bet that if the executive committee got a proposal at $500,000 a year, there would be a bit of sticker shock. I'm just putting a number on. Yeah. Total budget that goes in. It's not to say that it's an impossible task, but I'm just reacting for the executive committee, if you like. And I'm not on the executive committee, so it's easy to do. And on the low side, something like $200,000 a year would not be considered a very huge deal. So that's a fairly narrow range, actually. And I'm not saying that that's what you should do, but I'm just letting you know how steep the hill is as to what I would see the effort to go up the hill. Now, as thinking through this process, it's also interesting to consider modes of funding. So the current mode of funding for Compress is a single grant proposal. It goes to NSF. It has this umbrella. It covers everything from education outreach to beamline, blah, blah, blah. There's nothing to say that multiple grants are inappropriate. And there are some advantages for multiple grants. First, it really can identify different fields in an important way. And my, or at least one model I would have is that the president of Compress be the PI on these multiple grants, but they serve the communities in different ways, if that's a solution that would come out. Certainly discussion with the NSF people would be important in sort of putting that together. But one thing it does is it allows the reviewer community to sort of have input in a different fashion. And the role of a grant proposal that goes to NSF is to set out a certain review process that then evaluates that proposal and makes some kind of judgment on it. If there are sort of non-overlapping communities or sub-communities that get involved, then maybe it's better to have separate proposals that allow this process to work its way out. I'm not trying to promote this idea, but I'm just thinking that we should have the possibility here to think outside the box as we want to go forward with this. Okay, so I think there are a few challenges that this group can begin to face. And maybe part of this workshop is at least to begin to step towards those challenges. And the first challenge would be, what can we do as a group that we can't do as individuals? What is the holy grail of the system that we can approach as a group to get more access to national facilities, to get software development, to get support people that will enable everybody to benefit, and to the idea of leveraging existing facilities always plays well with NSF and others. The second point that one should emphasize here is, how can the enhanced infrastructure help students? And not only students when they're students, but when we have students that graduate, they go someplace else, and they have to be able to do research. And if all we've taught them to do is to use our machine, then they're disadvantaged, and they don't see sort of growth pathways. So part of the vision is to allow the field to expand and grow and sort of move laterally and still become a successful field in and of itself. And maybe the third challenge is how to do this for as little money as possible. Okay, so that's my input.
You mentioned something like the 200K that for the increase is kind of appropriate. You are talking about within this funding run, or you are talking about the new renewal for the 2020?
Well, I would say, in the mindset, what I'm sort of thinking of is, if I'm sitting on the executive committee and somebody comes in with a proposal that I don't know much about, what's going to frighten me, what's going to scare me away, and what is small enough that we could find a way to fit it in. So and this would include going for the new renewal. We were sort of, in the last renewal that Quentin was talking about, when we were proposing a fairly significant budget increase, I think we felt that our hands were badly slapped by NSF, because we made a very ambitious and, we thought, well-reasoned and carefully thought out proposal to grow, and we did not grow by $1. And
for the next round, are we going to try again, or learn the lessons?
Well, I think, at least my takeaway message from that time is that we really suffered a lot from the economic climate. Now, what the executive committee will do now, I can't say. I'm not even a member of it, so.
Yeah, there's two things that I would say that you said that are very, very critical. One is, I kind of know what will happen with discussions with NSF people, which you alluded to earlier. That what they will say is, sounds like a great idea, sounds like something credible, please proceed. But the thing is that what you want to do is you want to get an idea of what exactly their notion of their budget for the upcoming year is, and upcoming 2 years, upcoming 3 years. They know a lot better, or have, NSF, they seem to have this, they're plugged into the congressional gossip network, where they have a sense for what the budget might be, both from their director of NSF, in terms of what EAR is going to get, versus what the NSF as a whole is going to get. And so, I agree with Don's point that, the last time NSF was flat funded, there were other initiatives in our sciences that were ramping up and eating a lot of money. I think we were in a bad place in terms of being exactly synchronous with portions of Geoscope. I think we're in